Good afternoon, everybody. So I hope everybody is safe from the bad storms that happened last night. I know some of you may be dealing with some power outages and so forth, so just feel assured that I will work with you guys on that. Alright, so what we're going to do, and this is actually the last full week of class. What we're going to do this week is RLC Parallel Circuits. So I'm going to do this a little differently. So we're going to work a circuit. I'm going to go through just some basics, work a circuit, give you two worksheets, and the test this week is just going to be a circuit that you're going to work and then submit to me via Blackboard. So no multiple choice questions, nothing like that, just a plain old circuit that you're going to have to work, okay? Alright, so now that we have gotten past RLC series, so I looked at the test grades, and for the most part, they were excellent. Alright, so what we're in now is the resistive, inductive, capacitive, parallel circuits. Alright, so these are not much different than what we have already worked. So remember your rules for parallel. Voltage stays the same, current adds up to total, and then total resistance or reactance is always going to be lower than your lowest value. Okay? So all we have to do is just kind of throw everything in together. So in this portion of the video, what I'm going to do is I'm just going to go through the triangles. Alright, so in the series, the RLC series circuit, we had the voltage triangle, the power triangle, and the impedance triangle. So we have pretty much the same thing going on here, except for remember that voltage stays the same, so therefore we eliminate the voltage triangle, and now we have the current triangle. Alright, so this is just like when we did RL parallel and RC parallel. Really the only difference is all of our triangles are still going to have that subtraction for this side here. So that IL minus IC, XL minus XC. So the main thing that we need to remember is that when we are adding ohm values, so these ohm values include resistance, inductive reactance, and capacitive reactance. All of those are measured in ohms, so when we're adding multiples together and getting those individual totals, we have to do that reciprocal method. So for instance, if we have multiple resistors, we want to do the 1 over formula. 1 divided by 1 over R1 plus 1 over R2, and etc. equals the total resistance. And then the inductive reactance total is going to be 1 divided by 1 over XL1 plus 1 over XL2, and so forth. And then for capacitive reactance, it's the same thing. 1 divided by 1 over XC plus 1 over XC2, and so forth. So, again, it's just like what we originally were doing. We're just throwing inductance and capacitance into that same circuit. So it doesn't matter what kind of components we have here. If they are connected in parallel, always remember that voltage is going to stay the same. Okay, so voltage is going to stay the same. So, real quick, before we actually get into the circuit, let's run through some main formulas besides Ohm's law that you'll need to work these circuits this week. Alright, so number 1 is the impedance triangle. Okay, so remember one thing, impedance is measured in ohms. Alright, so impedance, Z, is the hypotenuse. And what it is it's the vector sum of the resistance and the inductive and capacitive reactance. Okay? But remember, since we are working with ohm values here, we do have to do that reciprocal method of this. All right, so your Z formula is a little bit of a doozy. Can I use that word? A little bit of a doozy, so I'm sure other people across the country, if they're watching this, are like, what does doozy mean? Anyway, so what we're going to do is we need to know this formula here, which is Z equals 1 divided by the square root of 1 over R squared plus parentheses 1 over XL minus 1 over XC close parentheses and squared. So in the next portion of the video, when we actually work the circuit, we're going to go through that together, okay? How you key that into your calculator, specifically with the TI-30XA, because if you have the fancier calculators like the TI-83s, 84s, and up, you can pretty much key this formula exactly how it looks, okay? And all this is in your formula sheet, so I did check. There's no errors in this portion of the formula sheet, so sorry about that. I was hoping that you guys caught that on the last video. I know I had some questions on the test. Some of you were not coming up with the correct answer, and it's because that formula was wrong, okay? So if you're trying to figure out what I'm talking about, go back and watch the last video, and I explain that. All right, so we have our impedance triangle, and then next we have our current triangle. So remember our rule in parallel is current adds up to total. All the individual currents in those branches add up to total current. However, I do have that out of phase relationship, okay? So basically what I have here is the triangle. So to convert this to a usable formula, we're going to have total current is equal to the square root of IR squared plus parentheses IL minus IC close parentheses squared. So it's still taking the difference between IL and IC and then squaring that. Okay? So make sure that you're not squaring every one of these. This is IR squared plus parentheses IL minus IC close parentheses squared and then square root. And then the same thing with the power triangle. It's just going to be your normal Pythagorean theorem with inside the parentheses the difference between vars L and vars C. So these aren't much different than what we've done the whole semester. Okay, so I'm going to try to make this circuit, or this type of circuit, just a little bit easier. So again, we're on that last stretch. Anyway, so from here, I want you guys just to take a moment, all right, and you should know your Ohm's law stuff. Okay, so remember, anything in this triangle is the same Ohm's law. It's just ohms, so it's voltage divided by current. Okay, anything in this triangle, so VA, P, vars L, and vars C, is all going to be voltage times current. And then anything in this triangle, so IT, IR, IL, and IC, are all going to be voltage divided by your ohms to get that. So we have that similar relationship in Ohm's law across all of the triangles. Okay? So I'm going to continue in just a few moments with working an actual circuit. So what I want you guys to do is I'm going to step out of the way. If you need to blow this up on your computer screen, I want you to write this down. And what we're going to do is that circuit that we're going to work the whole circuit just with these formulas right here in Ohm's law. Okay? Alright, so I'm going to step out of the way. You guys hit the pause button and record these formulas, and we will be back with a circuit to work.